Yeah. So coming to today's agenda, yeah. So this is the things we need to cover. We need to discuss as part of today's class. So introduction to Paired RDD. Then we'll see what are the different operations on Paired RDD. Then word count example. Okay. User pin case study. Then introduction to structure API, data frame and data set. Getting started with a data frame API. Then from pandas data frame, we'll discuss like how we are creating different kind of data frame, like from panda data frame, how we can create like Spark data frame and all. Then data frame operation, different data frame operation that we can implement. Okay, clear guys? So let's start with the first one, that is introduction to pair RDD. Let me scroll off. Okay. Guys, what do you mean by RDD? Just a quick recap. I have already discussed in my last class. RDD is nothing but the fundamental data structure of Spark data frame, right? So RDD is nothing but, I can say, the data structure fundamental data structure of you know Spark, SPARK, Spark data frame. Clear. So what do you mean by pair? Pair is nothing but two. For example, I told you, okay, pair of shoes. What do you mean by pair of shoes? So one shoes contains two pieces, like left side and the right hand side leg, right? Similarly, pair gloves means two. Pair means two, right? So one for left hand side, one for right hand side. Correct. So pair identity means obviously it's a combination of two different things in the single encapsulated a single thing. For example, I can tell, let's say there is a data structure called tuple. So tuple I can represent. For example, I'll tell employee name and its age. So I can represent name and age. For example, name is, let's say, Hari, comma age, let's say 29. This is one tuple, comma. Let's say another one is Srikant. Then age is, let's say, 31. Similarly, another one is called, let's say, what else? Prashant. Name is called, let's say, 38. Something like that. So this is a tuple. Same things if you want to represent in the dictionary format, then it will be like Hari colon 29, because key value pair, right? Srikant colon 31, comma Prashant colon 38. Here, so I can represent the data in any one of the or any of the data structure format, which is nothing but is kind of pair data. Okay, so let me share my PPT and I'll explain more. Now, pair RDD is a distributed collection of data with a key value pair. As I told you, in the dictionary, we can store as a key value pair. It is a subset of resilient distributed dataset, that is RDD. So, it has all the features of RDD and some new feature of the key value pair. There are many transformation operations available for pair RDD. Those operations on paired RDD are very useful to solve many use cases that require sorting, grouping, reducing some value and function. Commonly used operation on pair RDD are groupByKey, reduceByKey, countByKey, and join. So these are the example of pair RDD and all. Now, pair RDD are a special type of RDD in Apache Spark that contains key value pair. They are also known as key value pair RDD. Pair RDD are very useful for many data pre-processing tasks such as joining two datasets together, grouping data by a key, aggregating data by a key, sorting data by a key, and all. So these are the different operations we can implement on top of the pair RDD. Now you can see a typical pair RDD looks like this. For example, the stable source like data source maybe any database and all. I'm trying to extract the data like I'm creating different partition like partition 0, 1, 2, 3, and 4. And I'll try to implement all sort of transformation logic like it may be map, flatMap, filter, group by key, reduce by key, map value, coalesce and all, right? Then I'll implement the action that is count, collect, reduce, top, take, fast. This is a different action. Then I will get the result. Because as I explained in the last class, first I need to implement the transformation. Then after transformation, I will implement the action. Then only I will get and I will see the result. Clear, guys? Now, here is the example regarding creating the pair RDD, how to create it. So first, as I told you, 5 to 6 different ways are there to create the RDD. One is by reading from text file, sc.text file. I have to give the path of the file. That's how I'm creating the pair RDD. And on top of that, I'm using flatMap. What is flatMap? It's nothing but my transformation here. Flatmap operation, you can see. Flatmap. I'm implementing here. Okay. Now, to create a pair RDD, you can use the map transformation to map each element of an existing RDD to a key value pair. For example, the following code create a pair RDD from a text file, where the key is the word and the value is the number of times the word appears in the file. So you can see the example. Let's say I am working on a business case study called word count. Okay, so I'm reading the file that is my file.txt. I'm splitting on top of the space between the different word and all. I'm using flatMap transformation. Then each word, that is word.map, again another transformation. I'm using a lambda function, anonymous function, word, comma, 1. Means each word counted for one time. I'm writing is a kind of mapper because I told you in mapper generally always the value will be 1. Then in reducer part, it will combine all the value based upon a similar key. Then it will give me particularly a word is repeated how many times in that paragraph or like pages or whatever. Okay, now you can see that's how it will work. You can see same similar things I have explained in the map reduce program as well. So let's say in my file, my file.txt, that is my file.txt, this word is present or this letter is present. A, B, B, then C and D. Then what happens as part of map function, I'm trying to put the index, key and value. So here value is nothing but the actual value or word present in the file. Key is nothing but my indexing. And indexing starting from 0. That's why 0, 1, 2, 3, 4. So total 5 different words are there. Not different, five words are there. Okay. So that's why my index starting from 0 and end with 4. So 1, 0, 1, 2, 3, 4. Fantastic. Now, what I'm doing, I'm taking a list of key and value. So instead of taking key value as index and the actual value, now I reverse it. The value whatever taking, that I'm taking as a key, and as part of the actual value I'm putting 1. Means A repeated one time, B repeated one time, again B repeated one time, C repeated one time, D repeated one time. Fantastic. Now I am doing sampling. Sampling based upon what? Similar key only. Now A, comma 1. Because I'm taking the list of value. You can say list of value. Okay. Now B, it will be 1 comma 1. Why? Because B repeated 2 times. You can see B repeated 2 times. That's why I'm writing B 1 comma 1. Then C comma 1. Then D comma 1. So this is another B comma 1 is written by mistake. Okay, because I have already added here. Now part of reduce, what I'll do, A comma 1, fantastic. Now B is 1 comma 1. So it will add 1 plus 1 is equal to 2. Now C comma 1, then D comma 1. Okay, this B is coming by mistake, maybe typo error. Okay, typing error. Then list of key 2 comma value 2. So key is nothing but my actual word. Value is nothing but the number of times is repeated. So as a final output, you can see A comma 1, B comma 2, C comma 1, D comma 1. Means A repeated 1 time, B repeated 2 times, C repeated 1 time, and D repeated 1 time. If you try to cross validate with the input file also, you will get to know yes, A repeated 1 time, B repeated 2 times, C repeated 1 time, and D repeated 1 time. Guys, any doubt so far? Any doubt so far? Please let me know. No doubt? Then move to the next one. There is Paired RDD, the operation that we can implement on top of Paired RDD. So let me come back to the whiteboard. Let me explain. Operation on Paired RDD. Okay. So what are the different operations that we implement on Paired RDD? So let me write down list of operations that we can implement, then we'll see one by one. Okay. The first and foremost operation is reduce by key. Okay, reduce by key. Then the second operation is basically group by key. Reduce by key, then group by key, then join. After join, it will be sort by key. Okay. So these are the operations that we can implement on top of the pair RDD, guys. So let's try to see, okay, one by one, where we can use reduce by key, group by key, join, sort by key, and all. Okay, so before I get into to see what are the different operations and all, let me just give a quick recap what we have seen different transformation and action, because anyway it's required. TR transformation and action. Okay, so let me write down. Part of transformation, generally we have seen there is something called map. Then we have called filter. Then we have flat map. Okay. Then we have something called reduce by key. Then group by key. and so on. Similarly, here we have something called collect, count, take, show. Okay, like this we have lot many things. Other actions are also present. Now the time has come to see what are the different operation. Obviously, different operation we have seen. Now I'll explain in my PPT what exactly these things are doing and where we can use this. Okay. So after that, once we complete, obviously the word count example I think I have completed, right? So then we'll see about the introduction to structure API and now. Okay. Now let's see. Let me go back to my PPT. Now coming to reduce by key. Reduce reduces the value associated with each key to a single value. This operation is often used to aggregate the data, such as counting the number of times each word appears in a text file or calculating the average sales of each product category. Just sometimes before, whatever example I show you, this part, this is the part of aggregating only reduced by key because based upon a similar key, I'm trying to club or I'm trying to add all the value related to that similar key. That's why my count is coming as 2, even though the 2 times is present, right? Now, group by key. Group is the element of the RDD by key. This operation is often used to analyze data by category or group, such as analyzing customer spending by region or product category. Now join. Join two pair RDD together on a common key because you know whenever we want to implement the join operation between two table or a data frame, at least one column should be common between the two table. Then only we can do the join operation. This operation is often used to combine data from different sources, such as joining customer information from a CRM system with order data from an e-commerce platform. Now sort by key. Sort the element of the RDD by key. This operation is often used to generate a report or a data dashboard, such as a list of the top 10 product by sales or the customers with the highest spending. Now you can see the example. I am creating the object of Spark context. On top of the object that is sc.text file because I'm trying to read the content of a file. The file name is myfile.txt. Fantastic. Then what I'm doing? I'm trying to split based upon what? The space between the word, I can say. Okay. Now I'm storing the word. Then I'm using the map transformation on top of each word. I'm trying to make it each word comma one, each word comma one. Then I'm using reduce by key. See here, reduce by key. If I'm using reduce by key, then what happens based upon the similar word, it will try to add the value. That's why it's written x comma y is nothing but I will add x plus y. For example, first time word comma one, then let's say b comma one, then b comma one, then b comma one. Now it will become 1 plus 1 plus 1, that is 3. So final result will give me b comma 3. That will come by this line only, line of code, reduced by key. Similarly, generating a list of the top 10 products by sales. Product underscore sales is called sc.text file. Product underscore sales dot csv. Now product underscore sales underscore by underscore product underscore id is called product underscore sales dot map. There's lambda line dot split of you can see I'm taking the 0 index, then I'm passing float line of split of 1. So here what happens guys, I'm trying to, so there is a CSV file called product underscore sales which contains product name as well as the selling price. So based upon the similar key only, like which product, let's say iPhone, or maybe laptop, or maybe mouse, or what is the count, or what is the value, at which value I sell it. I need to add it up, like lambda x comma y colon x plus y. Then what happens? I'll sort it out because I want to find out top 10 product. So top 10 product means highest value will come first, then second highest value, then third highest value. So I will sort it in the descending order. That's why I've written sort by key false. What do you mean by false? False means higher value will come first, then lower value. Let's say, for example, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is ascending order. I'm starting from 1, go up to 10. If I store in descending order, then it will come first 10, then 9, then 8, 7, 6, 5, 4, 3, 2, 1. Here I'm storing in descending because I need top 10 product. Now take up 10 means like think about head of 10, like first 10 record I need to figure it out or find out. Okay. Now structure API. Okay. Now guys, coming to structure API, let me go back to my whiteboard again. So we have completed this one. Now introduction to structure API. Okay. Guys, any doubt so far? Any doubt in the RDD or no? RDD pair RDD or no? Because we are entering into a different concept altogether, that is data frame and data set. So any doubt so far regarding RDD and all? Now, coming to guys structure API, because coming to API, let me give a recall again. Coming to Spark API, generally we are dealing with three different component altogether. That is called RDD, which we have seen extensively from last class and today's class. Then second one is called data frame. Then third one is called data set. Now, RDD is not a part of structure API. It's unstructured and all. Now, coming to structure API, these two are belongs to structure API. So, when I'm telling structure API, this belongs to both data frame and data set. So, this is structure API. Now, you can ask me, Sarah, why? Because as you know, in our initial class, we have already discussed, data frame is nothing but the representation of the data in the tabular format. What do you mean by tabular format? Looks like a table which contains row columnar format. Means we should have certain column and certain row. Let's say this contains a value and all, and I have obviously certain column 3, 4, 5. Let's say this is employee ID, name, salary, address, and all. Let's say something else, phone number and all. Clear? So here all the values are present. Okay. Now, whatever data I'm storing in a tabular format or structured way. Similarly, data set is nothing but more than one data frame, collection of data frames, that is also a structure API. So when I'm talking about structure API, only two things should come in your mind. That is either it is data frame or data set. But most of the time we will deal with the data frame, so it should always come to your mind. That is data frame and data set. Clear, guys? Any doubts? So? Any doubts? So? Now let me go back to my PPT again. Let me explain. Yeah, you can see. Structured API are a set of APIs in Apache Spark that provide a high-level abstraction for working with the data. They are designed to make it easy to perform common data processing tasks such as filtering, sorting, aggregating, joining data and all. So these are the different tasks we are doing. So filtering, okay, sorting, aggregating and all. Okay, and joining also. Now structure API are built on top of Spark resilient distributed dataset RDD. And RDD are a low-level abstraction for working with the data in Spark. They are distributed across multiple machines and can be processed in parallel. Okay, because when I'm telling structured API, it's not just normal, we can just run on top of the local system and all. This is built on top of the Spark resilient distributed dataset that nothing but RDD. And as you know, RDD is a low-level abstraction for working with the data in Spark. And they are obviously distributed system and they are distributed across multiple machines and can be parallelly processed. Okay, you can see. So user code on resolve logical plan. So catalog, that is analysis and all. Resolve logical plan, then logical optimization and optimize logical plan. You can see one by one, we will see. Now coming to structure API, which are available in two flavor as I told you, either data frame or data set. So what is data frame? As I told you, data frame are a tabular representation of the data. They are similar to spreadsheet like in the Excel sheet, right? With row and columnar data. Data frame are a good choice for working with structured data such as data from a relational database and all. Similarly, what's about data set? Data set are a more powerful representation of the data than data frame. They provide additional features such as type safety, support for complex data types. Data set are a good choice for working with complex data such as data from a graph database or JSON data and all. Okay. Now, high level API. The code written using data frame abstraction is structured just like data frame is panda. The code is highly readable and easy to write. Therefore, it becomes accessible to a lot of people other than specialists like data engineer or data scientist. Memory management. Transformation or on RDD are performed in the executor. These transformations take place in the heap memory of the executor, which are essentially Java virtual machine. JVMs, on the other hand, data frames use of heap memory in addition to the heap memory on JVM. Hence, managing both heap and off heap memory requires custom memory management. As you go through the next couple of points, obviously we'll understand what is this all together. You can see. Introduction to structured API. As I told you, as part of API, Spark provides three different things. One is RDD, data frame, and data set. The RDD is nothing but data import and low-level coding application programming. But coming to data frame, table-based functionality like SQL-style query access. R or Python user will default to this as well. Now, dataset, more intensive application programming in Java requires class declaration and definition and all. Okay. Now, as part of structure API, as I told you, data frame and data set, these two are included as part of the structure API and all. Okay. Now, some of the important command that are follows. For example, like what are the different action or I can say different command I can implement on top of this structure API. One is called spark.parallelize method I can use. Another one is called collect I can use. Third one is to data frame I can use. Let's see. Spark context or parallelize. This command is used to parallelize data in Spark. It takes a collection of elements and distributed them across the Spark cluster, creating a resilient distributed data set. Now coming to collect, this command retrieves all the data element from an RDD or a data frame and returns them as a local collection in the driver program. 2DF, this command converts an RDD into a data frame in Spark. It infers the schema, that is column names and data types of the data, and it treats each element in the RDD as a row in the resulting data frame and all. Okay. Now, similarly, another two things also we can implement, that is a print schema and a show. Now, coming to print schema, guys, this command display the schema, that is column name and data type of a data frame in the structured and readable format. It helps user understand the structure of the data frame by providing the information about the column and their corresponding data type. Now, so this command displays the content of a data frame in a tabular format. It represents a concise representation of the data frame data, showing a limited number of rows in a visually appealing table format. By leveraging this command and techniques, you can efficiently create, manipulate, and analyze data frame in Spicebar. The ability to work with structured data in a tabular format provides a powerful tool for data pre-processing and analysis in various real-world scenario altogether. Okay. Now, to create a data frame from a RDD in Spark, you can use the 2DF method. The 2DF method take a list of column name as an argument and return a data frame with a specified column name. For example, the following code creates a data frame from the RDD name and pair. You can see here what happens creating the data frame. So basically, I am creating the object of Spark context. I'm creating the RDD by taking the parallelized method. Now, on top of the RDD, what happens? I will call 2DF. Then I will give what are the different column name that it should display while creating as part of the data frame. Then when I'm passing name and age, you can see the return type is data frame. DF. DF means data frame. Then I'm printing DF also. Okay. Now similarly, to create a data frame from a pandas data frame in Spark, you can use spark.create data frame method. The spark.create data frame method is a panda data frame as an argument and return a Spark data frame. How you can see same stuff like I'm creating a PDF with panda data frame. Okay, then a Spark session.builder.getter create Spark I'm creating. Then on top of the Spark I'm writing create data frame. I'm passing the panda data frame and it's creating the Spark data frame all together, and that I'm displaying here. That I'm displaying here. So what is telling? So try to understand. Let me come back to my whiteboard. Getting started with data frame API. Okay, clear? Now, so what are the things we can implement? Let me write down one by one. Just 1 minute. Okay. So one thing I can use that is first one is print schema. Then to display the output, I can use show method. So to convert RD to data frame, I can use 2DF. Okay. Similarly, to collect the all the output and store, so there's an action called collect. I can implement. So print schema basically I'm using to print column name and its data type. Similarly, show method is used to display result in the screen. Okay. 2DF is very very important, used to convert RDD to data frame and collect basically is the action used to collect all the result, action used to collect all the result. Dear guys, any doubts so far? So basically, this is among this obviously you will use a lot, but this is very frequently operation obviously so on this one and 2DA. As you know, there are different way how we can create the RDD, right? So one of the very simplest ways, like generally we are creating the object of Spark context. S is equal to Spark context. Okay, then we're passing something. Then SC dot parallelize, PARALLIZ parallelize. Then I'm passing let's say list like 1, 2, 3, 4. Okay, then it will create the RDD. Now, my question is this is RDD fantastic, but I want to create a data frame on top of the RDD. How to do that? Then RDD dot data frame 2DF. Then I have to pass what are the column name should be. Column name we have to pass. Okay, maybe it's ID, comma, let's say something else. Let's say phone number or age or whatever it may be. Then you can see the return type is RDD. Now, how to display the output? To display the output, you should not write print DF. No, this is not the proper format to display the data frame. This is a wrong format, I guess. You should not use this. What you have to use? You have to use df dot show. Okay, this is the actual format you can see. Proper format. That is show I am using. So I am using 2df. Similarly, for example, I have to print what are the different columns are there. Df dot print schema that you can write here. Df dot print schema, schema. Then it will give it a structural format like all the column name along with their data type and everything. Okay, everything will display. Clear, guys? Any doubt so far? So with this we have completed with getting started with data frame. Now pandas data frame. And different operation that I discussed, right? Okay, from panda data frame. Okay, from pandas data frame. Guys, sometimes before whatever I discuss, like how to create from pandas data frame means how to create. Basically, here I'm explaining how to create Spark data frame, right? Spark data frame from pandas data frame. Sometimes before we have seen how to create a Spark data frame from RDD. How to do that from RDD we have seen. From RDD we have seen that is by using 2DF function, 2DF. Similarly, from pandas data frame, how to do that? So first, let's create the pandas data frame. So pandas data frame nothing but PDF. Let's say I have created a data frame like something like I have created pt dot create data frame. So I'm passing the value and now that is for PDF data frame. So once I will create, that is Spark context object, that is nothing but this one. Now AC dot create data frame, I'll pass this PDF to here and it will give me return type as SDF. SDF is nothing but Spark data frame. Just try to understand. I'm passing this PDF into this one. Now this is nothing but my Spark data frame. And this is my pandas data. Clear guys? Any doubt so far? Any doubt so? Other things are present. So with this, I think we have completed the first part of today's agenda. Yeah, that's fine. Perfect. I have completed the first part of today's agenda. Now coming to the second part. Okay, let me just give the second part. Okay, that is this is pair RDD one, right? You might have seen the agenda. Pair RDD structure API one, then API two. Now API one is completed. Now I'm going to discuss about the structure API two. Okay, so let me give that heading better so that you can understand. Let me copy. This is API one. Now this is API two. Will we copy? Yes, fantastic. Now this is API two. Oh, sorry, API two. Yeah. Let me make it bold. Fine. Can I increase the size? Yeah. Okay, fine. Now what is the agenda? Let me set the agenda. Yeah. This is very interesting and important topic altogether. Okay. Now let's see the first one. We'll start the data manipulation in Apache Spark. Then consequently we'll see about the Spark SQL UDF, Spark repetition, Windows function, and descriptive statistics. Okay. So the first one is, let me start with the data manipulation. Data manipulation using Apache Spark. Guys, what do you mean by data manipulation? Let's first talk about what do you mean by manipulation. Manipulate. You might have heard this just normal English terminology. Okay, don't think about a technical perspective, the Spark point of view. Just think about simply English dictionary meaning. What do you mean by manipulate? Generally, we told, okay, could you please manipulate? Means something like could you please guess, kind of estimate kind of thing. So, okay. So, what do you mean by data manipulation? For example, you have given a data set, okay, raw data. You don't know what is present inside the data, right? Raw data. So, by using Apache Spark, you have to use a different type of transformation action and all. You have to make it structure like this on clean data. I can say it's on clean data. On clean data, you have to make it clean data. First of all, how to do that? For that, you are using different type of, as you know, transformation and action, right? Either transformation or action. I mean, both, obviously. Okay. Many number of transformation and many number of action you have to use, right? So once you use transformation and action, okay, then I can say you can convert the unclean data to clean data altogether. Okay, on clean data to clean data. Okay. Now, what are the different transformation action that I have written on the top? Exactly same things you can implement as part of your transformation or action based upon a requirement, and obviously you have to make it clean. Now, generally, the Spark is famous for, and for that, either you can go for using the Spark SQL module. Sometimes you can go for using Spark or module as well. If it is streaming data, obviously you can go for and using Spark streaming module. Spark streaming module altogether. Clear? Spark SQL module, Spark core module, Spark streaming module altogether. Clear, guys. Any doubts so far? Any doubts so far? Now, as part of this, once you make it clean, then this is ready for data pre-processing and all. So, as part of data pre-processing, so there are different steps are there. So, basically, we can say like data extraction. So, it's included in the ETL operation. ETL. So, what is the full form of ETL? So, L stand for load, T stand for transformation, and E stand for extract. So it is extract, transform, and load ETL. Okay. So as part of this, we are going for different pre-processing activity. What is those pre-processing activity? First of all, as you know, we have to extract the data. Once we extract the data, then it includes data cleaning, handling missing values. Okay, handling missing values. Then handling null values. Categorical variable conversion. Then implement different type of transformation as well as actions. Okay. Store data. Obviously display the data and store, or I can say store into data frame. Save data into either any file or databases, DBs. Okay. So as part of this, we have an important concept altogether that I should not miss, that is data wrangling. Data wrangling. Now, data wrangling is a wide perspective. It is a combination of all, like data cleaning, data mining. Okay, data cleaning, data mining. Then what else? data crunching, okay, splitting the data, splitting, whatever, all the things will comes under data wrangling only. Okay. So once you do, then I can say you will get the clean data, and that clean data you can store into file and DB. Now, sir, why you are doing all sort of hangama? What is the required? Guys, as part of data engineer or Hadoop developer, you are playing a very crucial role for data scientist team who are meant for building any model. Because to build a model, they need a right set of data, right set of data, right set of data. Now, once you will do or collect or make right set of data and store into DB, then only data scientists and people they can use this data set to build their model, build their either ML machine learning or deep learning model. But if you are not there, if you are not completing your task that to get the right set of data to build a model, obviously they can close their hand and they cannot go ahead a single step also. They are completely rely on you people, Hadoop developer or data engineer or ETL developer, whatever you told, all are the same. Because your primary job, roles and responsibility is to find the right set of data which is ready for model building and all. Clear, guys. Any doubts so far? Any doubts so far? Let me go back to off. Yeah. Spark SQL UDFs. Let me complete all the concept. Then at a time I'll go to my PPT and I'll share my PPT and see what are the other things there or anything I left or not. Okay. Spark SQL RDD. Guys, what do you mean by RDD? Sorry, what do you mean by sorry, I written wrong actually. Spark SQL, that is something else. UDF, Spark SQL UDF, not RDD. Sorry, it's UDF. Okay. Guys, what do you mean by UDFs? Any idea? So UDF stands for user defined interface. Okay. UDF stands for user defined interface. What do you mean by that? Generally, guys, what happens? It helps us. Okay, like as we have seen in Spark also, even if any other programming languages, it may be Java, Python, Scala, and all. They provide a lot of built-in, user-defined and predefined, I can say, method or function, by using which we can achieve certain task or activity, I can say, and which really help us to complete our task. But sometimes in the real time, whenever we work in industry, we get some complex tasks which we are unable to complete by giving the already available function and method. For that, we have to create our own defined function that is called user defined. Here, user is nothing but developer. So I have to define my function. I have to implement that. Then I have to complete the task. Let's say, for example, I'll give you example. Do you know how calculator is working? Simply in the calculator on the mobile phone, you are opening the calculator, you are pressing, let's say, 2 plus 2, then you are pressing plus symbol, then 3, then pressing equal to symbol is giving you 5. How that is happening? You do know. So behind this, obviously they have written a small software actually. So whenever you are writing or pressing those key button, automatically the software is working, means a particular function is defined, that is getting called and is executing, and you are getting the output. Let me write down that function. Let's say a user defined function you want to build. Okay, UDFs for, let's say, addition. Okay, this operation you want to do in the calculator, so I have written a UDF. What is that, for example? So first one is, let's say I'm declaring a function. I'm using the Python programming language. Okay, so let's say I'm using the black color better. Def, let's say add number, add underscore num. I'm passing two value. For example, that's a comma b. Hold on. The syntax I'm writing. If you don't know Python, that's well and good. Just observe it. Then I can see let's say any sum, or I can say the result is equal to a plus b. Now I'll write return result. Fine. So this is my user defined function. Then what happens? I will call this function. That's a rule, syntax. Okay. So I have to call the function like add underscore num. I'll pass to value. Let's say I'm passing 2, 3. Okay. And that is getting stored into that is called, let's say, output. And I have to print the output. Print output. So when I'm printing the output, guys, it will give me the result as, let me write down, it will give me the result as 2 plus 3, which is nothing but 5. It will give me the result as 5 direct. That's how the calculator works. But the thing is the how 5 is getting printed or displayed. That is the things we need to discuss. See, I have defined a function. Let me write down. So this is the definition of the function, I can say. So function definition. Can I write here? Yeah. Function definition. Here I am calling the function. This step is nothing but calling the function. So whenever I'm calling the function, I have to pass the number of value that I'm declared in the number of variable at the time of function definition. So here I have taken two different variable, means I have to pass two different value. Now two will go and assign and store into A. Okay, try to understand. This is very, very important. Two will go and store in A, and 3 will go and store in B. Let me make a jump and store in B. Now tell me, now here in the second line, result is called A plus B is nothing but, let me use the red color. So this is nothing but A plus B. So now A store 2, right? Because A is equal to 2 in the first line, right? And B is equal to 3 in the first line itself, which is assigned. Now A plus B is nothing but 2 plus 3. So now result is 5. Now that 5 is getting stored in result. Now the result store what? 5. Now I'm returning the result. Okay, returning result means the result is nothing but 5. Okay, fantastic. But if I write only return result, do you think that 5 will print? No. To print it, I have to call that function, and that value I'm storing in the output, which is a variable, and that output I'm printing by using the print statement. Whenever I'm printing by using the print statement like print output, then that result will display as 5. So this is my user defined function altogether. Clear, guys? Any doubts so far? Any doubts so far? Okay, fine. If not, let's move to the next one. That is Spark repetition. Everything will see. I will share my PPT and I will see once again. Okay, Spark repartition. So let me change the color. Okay, guys, what do you mean by repartition? Okay, there are two different concepts present in the Spark. Let me explain. One is called repartition. Another one is called colliers. Guys, there is a strong difference between these two concepts altogether. Even there is little bit similarity also there, but there is a strong difference between repartition and colliers. What do you mean by that? Let me see one by one. Guys, the repartition we can use either we can use increase in partition or decrease in partition. Now, colliers we can use decrease in partition. Only decrease in partition. There is no chance of increasing partition. For example, your requirement is to increase the partition. Now tell me which one I have to use. Obviously, increase the partition means there is no chance of using colliers, so happily you can go ahead and use the repartition concept. Now, for example, guys, your requirement is to decrease the partition. Now, there are two ways. Either you can use repartition or you can use colliers. Now, the question is what you have to use and why. Now, you can use both, not an issue. You can use repartition and collier, but generally, industry standard or people do prefer to use colliers over repartition if the requirement is to decrease the partition. Why? Why, sir? The advantages is in colliers. Okay, advantages is in colliers there is no shuffling involves. There is no shuffling involves in colliers, but here shuffling involves. As shuffling is a costlier operation, as shuffling is a costlier operation, so it takes lots of time for completion of task. But here, as there is no shuffling involves, it is much more faster than a repartition. TITI1. That is the reason why if your requirement is to decrease the number of partition, people do prefer to use coalesce than repartition. But if it's increase, obviously there is no other choice because you cannot increase partition by using coalesce. So you have to use repartition because there is no other choice at all. Clear? But if it is a decrease the number of partition, as you have two different choices, so among these two, people do prefer to use coalesce. Clear, guys? Any doubt so far? Any doubt so far? Please let me know. Let me see your chat box. To the next concept altogether. So this is completed, right? Fine. Windows function. Okay, guys. So what do you mean by this? Like Windows function block. Okay, fine. So let's see. Windows function is nothing but it's a kind of range in between which we need to figure it out. For example, I'll tell you. Let's say I will take a data frame. Okay, it contains let's say certain values, certain columns altogether. Okay, let's say I'm taking the employee data set. It has employee ID, EMP ID, EMP name, EMP salary, let's say EMP address and all. Okay, EMP address and all. And I have taken let's say few row. 4 5 rows I have taken. Okay, so let me figure it out some value. Let's say this is 1 2 3 4 5. Employee name, let's say X Y Z A B. Salary 10K, 20K, 12K, 15K, 22K. Address Bangalore, Chennai, Hyderabad, Delhi, Agartala. Clear? Now, whenever I'm telling window function, so obviously I have to define a window size. For example, let's say my window size is equal to 3. So my W is equal to 3. My window size is equal to 3. Let's say I will start from here, like the first index number, let's say is 0, 1, 2, 3, 4. So when I'm telling window, let's say I'm here, but I already moved from here to here, 0 to 1. Now my position, my cursor present here. Now when I'm telling window 3, now starting from here, go up to 3 means included this one, this one, this one, 3 row. Now that will be my window function. It contains this 3 row. So if I find out, okay, find out the average of this window 3, then average salary I have to find out. So add this 3, 20 plus 12 plus 15 divided by 3. If I tell window 5, then my window 5 will be like this because here 3 row, I will include another 2 row. That's nothing but this one. All the row. That means all the row. Window size is equal to 5 here. My window size is equal to 5. Clear, guys. Any doubts so far? So based upon my window size only, I will decide Okay, how many number of rows I need to take care or I need to include as part of my calculation and all. That's all about Windows Search. Obviously, I will show my PPT and there you will get much 100% clear. Okay, fine. Now the next one, I think the last one is that, yeah, descriptive statistics. Guys, what do you mean by descriptive statistics? Basically, statistics is nothing but a methodology by using which we can take care of the data skewness, data scattered and all. So a famous core present in statistics that is called bell curve. Let me draw that one first. Then I'll explain. You might have seen this. Okay. Have you seen such type of diagram anywhere? Definitely. In a childhood or maybe statistics you might have seen. This curve we call it as it's a kind of bell-shaped curve, right? Like kind of bell curve, or we call it as Gaussian curve, or we call it as sometimes, uh, obviously this is normal distribution or Gaussian distribution, normal or Gaussian distribution. So what is telling? So the middle value is nothing but zero. That is mean value. So mean value is equal to zero. Now my data is present in the scattered manner, irrespective of the some variance or no. So I'll take some value. For example, let's say I'll make it dotted mark. Let's say it's my first variance. That is, I can say sigma, and this is something like my minus sigma. This is my second variance. Let's say 2 sigma. This is in the negative axis, that is minus 2 sigma. Similarly, here a third variance, that is 3 sigma, because one step keep on increasing, and here my minus 3 sigma. Clear, guys? Clear. Now, according to the research, scientists they are telling maximum 68% of the data present in this region. In this region means this region. Can I take a different color altogether? Let me see whether it's possible or not. Then I will try to. Oh, what is happening? Yeah. Let me use this one, this portion. Let me pull it. Clear, guys? 68% of the data present in the first quadrant itself. I mean the first variance in the range between minus sigma to plus sigma. Clear? Now, around another, I can say 92 to 95% of the data present in between minus 2 sigma to plus 2 sigma. So let me take a different color altogether, if possible. It's very taking time, I don't know, while selecting. What is up? Yeah, oh, it is come. Let me take this color, okay. So let me fill with that color. Clear? Now, 97% of the data, or I can say almost 99% of the data present in this area. 99.95 I can say. So let me take a different color. Take this. Okay. Almost all the data, like 99 point, let me put it 99 point. So only 0.05, 0.05, right? So 99.99 something. 98 and 99% of data present in between this. Rest of the things which data is present outside of this 3 sigma, let's say there is a data point present like this. Let's say here also some data point, data point, data point, here also some data point. I can ignore those data points because that is not at all required, because almost all the data point, 99%, 99% of data I capture in this region only, that is minus 3 sigma 2, minus 3 sigma 2 plus 3 sigma. Clear, guys? That's all about the descriptive statistics. And here we play around different terminology and all. For example, as part of data pre-processing, let's say while extracting the data from source system, let's say you have 40 columns related data are present. Do you think that from the source table, right? Do you think that all this 40 column related data is required for your further analysis? Not required at all. Obviously not required at all. Maybe client to know I don't need all the 40 column related data. I need maybe 12 to 15 column related data. It is a client requirement. Client requires. Now, guys, the point is, the question is, how do I select which 10 to or which 12 to 15 columns are important out of 40 columns? That is challenging task altogether. To do that, it provides a lot of statistical methodology. There is something called, let me tell you, there is something called p value, that is probability value, p value. What is that p value? According to p value, I'll find out the p value for each and every columns altogether. If my p value is less than or equal to 0.05, which is nothing but a threshold value, okay? 0.05 is nothing but a threshold value, okay? Nice. Color is not changing. Yeah. My p value is nothing but 0.05 is threshold value. Then I can say I have to select those columns. If my p value is less than, sorry, greater than 0.05, then at that time I can say my that column is not important, so I can drop those columns. I can drop those columns. Clear, guys? Any doubts so far? I can drop those columns. So this is a probabilistic value I can say. This is a kind of probabilistic value or statistical methodology. I can statistical value. We used in probabilistic value used in statistical modeling. Okay. Similarly, there is another one is called VIF. Let me complete this one, then we'll wind up. Okay, VIF. What is VIF? VIF stands for variance inflection factor. So according to this, so there is a certain formula for that. Let me write down first. VIF. Okay, let me write down the condition first. In VIF, again, same things. If it less than equal to 0.5 and greater than equal to 0.5. Okay. If less than equal to 0.5, obviously accept or select. Why the color is not changed? Select those column. Here, reject or drop. Don't consider. Okay, drop those column. Drop those columns means, for example, out of 40 columns, if you find out the VI value for a particular column is more than 0.05, don't consider that column, drop it. Then go for another column. Like this, you have to find out. Okay, so those are column. So VIF generally, so let me go to box. Drop those columns. Okay. Now, generally, typically, the formula of VIF is equal to 1 by 1 minus R square. What is R square? So this is basically we define R square is nothing but 1 minus RSS divided by TSS. I mean, just for your knowledge sake, I'm writing. Anyway, it's not required for you. You don't need to find out anything manual. Okay. Clear, guys? Clear. So with this, we have successfully, covered all the topic today's agenda. Now let me go back to my PPT and I'll explain. I'll share what are things I have explained in the whiteboard. Same things written and any other extra things also there we can cover up in the PPT itself. Okay. So without any delay, okay, let me go back. Yeah, you can see the data manipulation in Apache Spark is the process of transferring the data into desired format or structure. Spark provides a variety of tool and API for data manipulation, including data frame. Okay, so data frame is nothing but a distributed collection of data organized into named column, basically. Okay, and data frame can be used to perform a variety of data manipulation operations such as filtering, sorting, grouping, and aggregating data. Now, SQL. Spark SQL is a module that allow user to interact with the Spark data frame using SQL queries. Spark SQL supports a wide range of SQL operation, including filtering, sorting, grouping, aggregating, and joining data. Now, RDD, regional distributed dataset. Obviously, we have explained in depth. I don't need to go through that. Now you can see what are the different operations we can do: filtering, sorting, grouping, okay, aggregating, everything we have done, aggregating, joining, and all. These are the things we can implement on top of the Spark data frame and all. Now coming to UDF, as I told you, we can do data cleaning and data pre-processing, feature engineering, statistical analysis, and machine learning all together we can use. Okay. So here is giving the example. I've taken the example of calculation like summation or addition. How a small software is written behind the scene for the calculator and all. Okay, this is similar stuff. It is written here. Okay. Now Spark repartition, as I've explained. The repartition is the process of changing the number of partitions in Spark data frame. Either you can increase or decrease. Okay, but by using Colliers you can only decrease. Okay. Now you can see how it looks like the operation. You are reading the text from the text file. Then you are implementing the map. We have seen in the code also today. Then you are implementing group by. Then after group by map value, then repartition. And after repartition, you are implementing flat map, then reduce by key. Okay, so total stage you are able to see, right? Now potential drawback of repartition, as I told you, is a costlier operation. Why? Because sampling happens. Repartition can create more partition which can increase the overhead of managing the data. Now repartition can make it more difficult to reason about the distribution of data across the cluster altogether. Now you can see this is the code I have written, code snippet. Okay, how to create the repartition and all. Okay, you have just done like data frame dot repartition of 4 means 4 partition it will create. Now current partition is 1 by default 1. You have increased to 4. Okay. Now window function. So let me show you the diagram. Yeah, I was talking about this diagram in my whiteboard while explaining. See, so it has taken 5 different rows. If my window size is equal to 1, so visual representation of the frame row between 1 preceding and 1. So for example, my current location is here. It will just take 1 preceding, 1 following if my window size is equal to 3. If my window size is equal to 4 and my current input row is this one, then it will take 2 preceding, 2 following. Are you getting my point? Here is written 1 preceding, 1 following. Current input. Okay, what are the different steps involved as I told you, like path of data wrangling and all. Now descriptive statistics. You can see here carefully. So here you can see the mean, median, mode, all are the same in the middle part. You can see the middle one. Mean is equal to 0. Descriptive statistics are a set of statistical methods used to summarize and describe the main features of a data set. This method can provide a clear and concise overview of the data and can help you identify patterns, trends, and relationships. Okay, so I have explained in depth in my whiteboard. Actually, it is just written, it's just small, description, not giving much altogether. Now there are two main types of descriptive statistics. What are those? First one is measure of central tendency. Second one is measure of variability. Now let's try to see what is measure of central tendency. These measures describe the typical value in a dataset. The most common measures of central tendency are the mean, median, and mode. Similarly, these measures describe the spread or dispersion of the data. The most common measure of variability are the range, variance, and standard deviation altogether. Okay. Now, coming to the descriptive statistics can be used in a variety of ways, such as to describe the characteristics of a population or sample, to identify patterns and trends in data, to compare two or more group of data, to make prediction about future values and all together. Okay. Now, guys, so these are some poll question. If you can tell, that is very great. Which of the following is a tool that can be used to manipulate the data in Apache Spark? Could you please tell me? Which of the following is a tool that can be used to manipulate the data in Apache Spark? So obviously we are using manipulation, right? Manipulation means obviously we are using the data frame, UDFs as well as RDD. So all of the above is the answer, right? Similarly, what is the purpose of Spark SQL UDF? To extend the functionality of Spark SQL, correct? To improve the performance of Spark SQL query, no? To make Spark SQL query easier to write, no? All of them. So answer A is the correct option. Similarly, what is the purpose of repartition of Spark data frame or RDD? Just sometimes before I told you. To improve the performance of certain operation, correct? To distribute the data more evenly across the cluster, correct? Why? Because if I create more number of partition, so more number of data will be splitted across the cluster and it will present. To reduce the amount of data that needs to be transferred between workers, correct? So all of the above. So all of the above is the correct answer. Clear, guys? Any doubts? Any doubts? Coming to summary, guys. Spark provides a variety of tools for manipulating data, including Spark data frame, Spark RDD, and Spark SQL UDF. All these three. Spark SQL UDFs can be used to extend the functionality of Spark SQL. Spark repartition is the process of changing the number of partitions in a Spark data frame or RDD. Either it will increase or decrease, but in case of Colliers, it will only decrease. Window function in Spark are used to calculate result over a set of rows. called a window that are related to the current row. Similarly, descriptive statistics are a set of statistical methods used to summarize and describe the main features of a dataset altogether. Clear, guys? So that's all about the summary or today's agenda that I have set. So with this, we have successfully completed the today's agenda, that is pair RDD Spark structure API 1 and API 2 both. Okay. So API 2 we have completed successfully. Okay. And similarly, API 1 also I have completed successfully. Okay. Fine. So as part of next class, obviously we'll go with a new concept altogether. Let me set the agenda. In the next class, we'll see different components of effective data architecture. Okay, what are the different components we use as part of architecture and all? Okay, so we'll see the agenda and set what are the things we need to cover as part of next class, and that we'll see in details in the next class itself. Okay, clear, guys? So today's class, today's agenda is fine. Today's class is okay, absolutely great. Okay. Fine, guys. So if you have a Telegram channel, please join the channel that I pinged on the chat box. Okay.